In 600 BC, a Greek named Thales first described a unique property of the gemstone amber when rubbed against fur or wool. Such stones were able to attract small pieces of straw or paper. It is from the Greek word for amber, electrum, that we get the name electricity. You don't need to go for looking amber gemstones to see these effects. In fact, there are many materials which, if rubbed together, produce the same effect. This phenomenon is also known as triboelectricity or frictional electricity. We can perform an experiment using glass rods. Let's say we rub two glass rods on wool and suspend one of them with a silk thread. If we bring the other rod close to the first one, they try to push away from each other. Replace the glass rod with a plastic rod rubbed on a cotton, and you see that the glass and plastic start attracting each other. We can interchange the positions of these rods and we still get the same results. This means that different materials, when rubbed together, acquire a property of repelling or attracting certain objects. Charged materials can attract or repel each other. This implies that there are at least two types of charges that can exist on an object. This quality is what we called the polarity of charge. When charged objects that have opposite polarities are brought in contact, they lose their charged properties. This implies that charges can neutralize each other. But let's try to refine our experiment to get a more qualitative understanding of how charges work. This is an electroscope. It helps us to determine the quantity of charge that is being transferred between objects. It consists of a metal rod and a metal knob that are connected to a very thin gold leaf inside the insulating enclosure. The metal knob can be charged by touching it with other charged objects, for example a glass rod or something. The presence of the same type of charge on both halves of the gold leaves allows the leaves to diverge, and removal of excess charge causes the leaves to collapse. This divergence and convergence of the leaf halves gives us some understanding of the both quantity and type of charge are being transferred. Before we conclude, let's summarize this session.
Manorama Horizon. Learning made simple.